Thank you. Thanks very much for the intro. As I said, it's lovely to see such a nice big group online. And I caught the most of the last talk, which was absolutely fascinating. So well done. I want to talk today about the water, environment, food nexus, but maybe in a way that will be novel to many of you, unless some of you have seen some of my recent talks. So yeah, hang on to your hats. I think we've got some interesting ideas. I think I've got some interesting ideas to share. If I can, how do I go forward? Here we go. I just got to press the. Okay, I figured it out.
Yes.
All right. So let's start. I'm going to talk about three main areas. Firstly, the origins of what we now call the water, environment, food nexus, or the WEF nexus. Where does it come from? And I don't mean where does it come from in the policy sense. I mean, like, how is it that we find ourselves in a situation as a species where we need to consider our interaction with environment, food, and water constraints? Where did that come from? So I'll talk about origins because I think that we, in many ways, are quite grotesquely ignorant of our deep history. And it's high time that we updated that, and particularly in our teaching of our students. I'll then talk about trends in the WEF nexus and prospects. So just a view into the future and what could be waiting in store. So and apologies to people who've listened to some of my recent talks. I'm just going over a few basic concepts. The first point to make when we think about where we are today as humans is to properly understand what is our deep evolutionary history. And that starts with the phrase for me that we were born in the Ice Age. Our species has its origins in the Ice Age, the Pleistocene epoch, and we're about 300,000 years old as a species, maybe a little bit older. There's some interesting new evidence coming up that suggests closer to north of 500,000. I'm not so sure, but nonetheless, we have, for the vast majority of our time on this planet, we've lived in the Pleistocene epoch. And it's quite an extraordinary story because we can unpack the climate and the atmosphere of the Pleistocene epoch, at least partially. It's a 2.5 million year old age or epoch, but we get to about 1 million years back in time, 1.2 million, by drilling these cores into the ice caps of Greenland and the Antarctic, where the ice is several kilometers thick. And because it accumulates every year, because we're in an ice age, the ice doesn't melt. The ice at the bottom, which is formed from snow that fell ages ago, is up to 1.2 million years old. And the amazing fact is that as the snow falls, it traps these little bubbles of air. And as it gets compressed into the form of ice, as you can see these little bubbles of air. Now, those are a very faithful, they capture very faithfully the state of the atmosphere those hundreds of thousands of years ago. We can melt that ice, extract the air, and do analyses. Interestingly enough, we can also look at footprints of our earliest ancestors. We're not a very old species. We haven't been around for very long in the context of most species. So that's extraordinary. And that tells us a lot about our current predicament as a species. Our current predicament is that we dominate our planet. We're warming the climate, warming the atmosphere, and causing climate change. And we've introduced a whole lot of different changes, which I'm going to outline, which lead to this issue of the water, environment, and food nexus. So if you go back over our deep time, you can see this is the present on the right here, back 200,000 years ago, 400,000, back to 800 in this particular ice core. And you can see that the CO2 level fluctuated between about 180 parts per million and nearly 300 parts per million. So very low CO2 levels. CO2 levels really low enough to even threaten the existence of trees, because trees require a lot of CO2 to grow their trunks and their roots. Trees prefer higher CO2. Grasses do very well at low CO2. And then matching the CO2 trend, the atmospheric temperature, which roughly tracks it. It's not precise because CO2 tends to lead temperature. And these natural fluctuations, you'll see that there are warm periods and there are cold periods. But most of the last 2.5 million years has been much colder than it is now, much colder, 5 degrees on average around the planet, maybe 7 degrees. So most of the time that we've been around as a species, our planet has been much, much colder. Pretty interesting. We only think that the planet is nice and warm because most of modern humanity has lived in this little era, the epoch called the Holocene, where it's been warmer. And it warmed naturally at the end of the last glacial period because of the way the Earth circulates around the sun, its tilt, its wobble, the shape of the orbit. These all affect the energy coming into the atmosphere, and that interacts with the carbon cycle and the hydrological cycle to drive this sudden warming. But you'll notice that it's a bit like a heartbeat. It never really exceeds 300 ppm here, and it never goes below 180 ppm. And that's pretty much because of the planetary constraints from ecosystems that stop CO2 from exceeding these levels. But we've come along and we've changed that picture. So that's a fundamental background. We have a long history scrabbling an existence on the edge of extinction on a very dry, cold, and unproductive planet. Isn't that fascinating to think that we've been on the edge of extinction until a few thousand years ago? And you should be asking yourself a question: why did it take us so long to become dominant on our planet? We've been around for 300,000 years. We've been dominant only for a few thousand. What happened? Is it all just a social development of humans, or is there something deeper? Is there something more quantitative going on? And I don't believe in the hand-waving explanations. I think that this is mechanistic, and I'll explain why. So if we look at what the world looked like and what the food, water, energy situation was facing our ancestors in a cold world, this is what it looks like. So here is the biome, the extreme desert and forest biomes under pre-industrial levels. Green is forests, yellow deserts. But if we go back to the last glacial maximum 18,000 years ago, when CO2 was lower, the world was colder, the world was drier, you can see that for most of the last 2.5 million years, tropical forests have been a much smaller extent. They've been almost themselves on the edge of extinction, and they're really limited to the warmest and wettest parts of the world at that time. The deserts expanded and the grasslands expanded across Africa. That is the status quo for much of the last 800,000 years, but we know now probably most of the last 2.5 million. That's the environment in which we had to develop as a species. And we didn't develop very much. We were hanging on for dear life, I suspect. But I think we had a lifestyle which is quite interesting. So that's the cold, dry world of our history, our deep evolutionary history. And then about 9,000 years ago, the world actually reaches a much warmer state. I wouldn't say it's a hot state, it's a less cold state. But this happens, as I said, naturally. And now we can start to ask the question, well, this world that came into being naturally, which lasts only a few thousand years, every 100,000 years or so, as you can see, is a more productive world. It's a higher CO2 world. It's warmer. It's wetter. There's more forest. There are more trees. There's more production. And is there something to that which might explain how we became dominant as a species? It became warmer and wetter for long enough. So let's just summarize quickly. This cold world on our left, which was most of our history, is a carbon-constrained world. It's cold, dry, unproductive. There's limited food. There's limited wood. And I would imagine that there is a strong dependency on a coastal lifestyle. Why do I say that? Well, for a number of reasons. It looks like humans in general suffer from iodine deficiencies more generally. Go and have a look at it. That's why we add iodine to our salt. We suffer from omega-3 deficiency, which leads to all sorts of mental health problems. And why would that be? I suspect it's because we've got a long history of living off an ocean-based diet. And I think you can also see that in the way that the humans spread across the planet from Africa. So Homo sapiens has an African origin. So we're essentially all African people. But at different times in the last few 100,000 years, Africans have colonized the rest of the planet. We are a very colonial species, actually, we Africans. So you can see about 160,000 years ago, over here, Homo sapiens expanded towards the east and into coastal regions and towards the south. Nothing much happened around 115 to 85,000 years ago, which is a period of an interglacial. So we just stuck around. And then when it got colder again, you can see that us Africans invaded the rest of the world, mainly by walking along coastlines. You can see our coastal distribution here into Asia, our coastal maneuverings into the Mediterranean region and into Australia and into the Caribbean, all these areas. That is a coastal dispersal pattern. I'm not showing the South America pattern because I think it's very contentious and I think it's going to be revised. I think the invasion of South America, the original colonization of South America by Africans occurred via the Southern Pacific, but we'll wait for the evidence to come in. So that's why I think that we have a coastal dependency traditionally. So just to summarize then, our origins are that we come from a world of unproductive drylands. We have had a carbohydrate constrained diet. That is, our food constraint has been heavily carbohydrate limited historically. We have had a nomadic lifestyle, and we've had a coastal environment dependency with a question mark there. It's a hypothesis. We'll see. One reason that's difficult to test that is because those migration routes are now all underwater. And I would hypothesize that if we were to send divers down to the ancient coastal areas of the Pleistocene, we would find evidence of our history as a coastal species. Sadly, we haven't been able to do that. But there's one place where we've got evidence, and that is in the Southern Cape, near Mossel Bay, where it's very clear that we had a strong coastally dependent lifestyle. And I think that's a clue to this whole story. But it hasn't been interpreted that way yet. So what changed? Well, as I said, CO2 rose at the end of the last glacial. And we moved from a very cold world into a much warmer world. Not a hot world yet, but that's kind of what happened. We see a 33% rise in CO2. And what do we see humans doing? Well, they start making a whole set of new tools. They start to make stone tools that can be put into the horns of animals and into the curved pieces of wood, branches from trees, to make sickles. So these sickled stone tools suddenly become much more common around about this time. And my hypothesis, and it's not the first time it's been proposed, was proposed by Rowan Sage in 1995, was that the low CO2 during the Pleistocene limited agriculture. And as CO2 rose, so agriculture became possible. We became farmers. That is a fundamental change in our lifestyles. So we lose our coastal dependency and we become farmers. What's the evidence? There's incredibly good evidence, because what we see in the stone record, and as you can see, I'm giving you a transdisciplinary talk here. I'm drawing from multiple disciplines and making them work together. This is quantitative transdisciplinarity. I'm not just telling a narrative. I'm really trying to give you some evidence. So these are the sickle cells of that time. sorry, the sickle stone tools of the time, not sickle cells, what I'm thinking about. And you can see that from about 9,000 years ago, the frequency of these sickle blades just explodes in the Levant, in Turkey, in the Middle East. That's where agriculture was invented. And there are a number of different sites where this can be shown. This really marks the end of the Stone Age. So the Stone Age is marked not by a reduction in stone use. It's marked by an explosion of stone use. It's a little bit like the Coal Age, which is going to end with a bang very soon, just as we finished Medupi and Kasili, sadly. But anyway, so these stone tools became very, very common. And at the same time, if you look at the records of cereal use by humans at that same time, you can see the proportion of the diet that we understand humans were using increases radically towards cereals. That is a significant shift. So we go from this coastal dependence, low carbohydrate diet into a different kind of a diet. And the reason is that with CO2 rise from the cold to the warm, we see that the yield of wheat is extremely sensitive to this. These are experimental results showing that at low CO2, wheat yield is reduced by 60 to 80%. It made no sense to be a farmer under these conditions. But humans quickly noticed as CO2 rose that these crops were becoming more productive. And there's a whole story to be unpacked about how that happened. And we've got some great archaeology to draw on. Sadly, the archaeologists haven't clicked about the value of CO2, net primary productivity, and they're still faffing around with questions of well, different kinds of questions. But I think that this is going to unlock a lot of better understanding of how settlements like Çatalhöyük and Göbekli Tepe, Karahan Tepe, and others can be explained and can be interpreted better. Anyway, we'll get there. Hopefully they'll wake up. One of the other crops that really takes off, it's not only wheat and cereal crops, it's also fruit. So we see here from modern experiments done on fruit trees and seed production and fruit production in relation to CO2. Here's our glacial CO2 and our interglacial CO2, where humans started to really flourish. And you can see that the production of fruit takes off, seeds and fruit. What does this mean? It means that we didn't traditionally eat fruit, seeds, wheat, bread until very, very recently. This is a very recent invention. This explains why we have so many problems, health problems, like gluten intolerance and things like that. It's because we've only been eating these crops for a very short period of time. I know this is shocking information, colleagues, but it seems to be very real. So let's think about WEF constraints, water, environment, and food at the global level today. What I'm showing you here is a map of the world, an atlas of the world, but not in space. I'm showing it to you in rainfall and temperature space. So mean annual precipitation and mean temperature on the X and Y axes. And you can see that where you have a lot of pixels on the planet that are replicated in a certain climate state, they get a red color. Where there are few, they get a green or blue color. So you can see much of the world has a fairly low rainfall, under 1,000 millimeters. That's all this red here. And quite a bit of it is cold. So this is cold, getting warmer, and we see we've got this really warm, very wet tail, excuse me, to this distribution, which is the tropics, which is not a huge portion of the planet. But it's very, very productive. On these same axes, we can plot two other very strong determinants of food and water, the food and water elements of the nexus. So in terms of water and temperature, NPP, net primary productivity, is highest here at this part of the niche. And soil fertility is highest where rainfall is lower, because high rainfall tends to leach soils. Very high rainfall leaches soils of their nutrients. So if you want to be a farmer, you're essentially stuck between these two constraints. You're stuck between a soil fertility and an NPP constraint. Can you see there are these two divergent constraints? It's difficult to farm the planet because of this. And the story of agriculture, as you probably know, is one of irrigation and fertilization. Let's go further. I'm jumping the gun a little bit. Now, where do people fit? It turns out that we sit in a niche that is directly between these two constraints. And I'm showing you this niche for two periods of time. So this is deeper time, 6,000 years and earlier. We can see that human distribution, based on the archaeological record, is quite broadly distributed across this temperature and rainfall space. We have quite a large niche, and it's because we're trekking along coastlines, we're moving into semi-arid regions where we can hunt, where we can scavenge, we're hunter-gatherers, and so we have a very broad ecological niche. That's our deep history. But 500 years ago, this is the human niche, our niche changes. Our niche does something extraordinary. Our niche actually shifts. That is rare in ecology for a species to experience a niche shift. It's very rare. So the human niche radically shifts from being a low carbohydrate dependent niche into a high carbohydrate dependent agricultural niche. That is the history of our species. That is the origin of the water, energy, and water, environment, and food nexus, is this niche shift, which happened recently. It happened a few thousand years ago at most. Isn't that amazing? We've expanded our niche somewhat now because we've got high tech, which is why we look at 500 years ago before we have significant agri-tech. And you can see that our niche is reverting much more to the ancient niche, but it's because we've got technology, we can irrigate, we can fertilize, and we've got transport, so we can trade food around the planet. And that shows, and we can also see how our crop niche, livestock niche, and our GDP niches relate to our agricultural niche. So our origins are now that our modern origins are that we have developed a new niche. We've shifted our niche according to a warmer, wetter, more productive world. We've shifted onto a carbohydrate-rich diet with all the attendant health problems, which, by the way, means that most of medical science is behind the curve and does not take into account this issue. And it's sad that we're not teaching medicine, I would imagine, correctly in terms of nutrition. We've moved from a nomadic to a settler lifestyle, which has all sorts of political and socioeconomic implications. And again, I think a lot of our social scientists have missed this and do not teach social science and the true history of humans correctly. And we now shift to a land and water dependency from a coastal dependency. We now sit in the nexus. We've trapped ourselves in a carbohydrate trap. We become, it's a carb trap. And that is the origin of the water, energy, food nexus, believe it or not. Extraordinary. So what are the trends, given that we're trapped in a carb trap? Well, we now have figured out how to uncool the planet. And as you can see, if you look at the temperature history of the last few thousand years, we were moving back into an ice age. Remember, most of the last 2.5 million, it's been glacial. The interglacials are very short, a few thousand years at most. This one's been one of the longest. And we were on our way back down until we invented fossil fuels and agriculture to some extent. The invention of methane, rice farming and methane emissions has somewhat turned us around. But it was fossil fuels that started to warm the planet back up again. And we began to geoengineer the planet without any strategy. It was just by luck, because the Brits figured out how to burn coal and drive an industrial revolution, which then further changed the world. But we started to warm the world, and we warmed it back into what I would say is our sweet spot, which is where we've developed this high carbohydrate dependency. Our challenge is that we've warmed it too much, and we now face this issue. We're overcooking the planet. and that's a problem. But and you can see the trends in temperature show that this is a reality. If you don't believe these temperature curves, you do need your head read. But let's not go further on that. But when it comes to the environment and to land, our entire relationship with the land has shifted as well. And that is due to high tech. So we've gone from needing more than nearly 3 hectares to support a single person to today much less than half a hectare. This is a complete shift in the land dependence of modern humans. It changes, it devalues land in many ways. The smallest nation on earth, the Netherlands, produces more food than almost any other nation on the planet. It's a complete shift in mindset in how we produce our food. So the food element of our nexus is highly modernized, and it's in a completely different space. Unless you want to revert to a sort of more ancient lifestyles, which is quite difficult in a warming world. And at the same time, our world population has exploded. And this graph is often used to scare us into thinking that somehow we're going to ruin the world. And while that may be true, I think it is mal used as a scary trend, which I'm going to return to. But we've also, as I said, increased the productivity of the planet. And part of the output of that is that we've increased the biomass of mammals enormously on our planet. And that's due to a warmer, wetter, more productive world. So there were probably about 20 million tons of megafauna, of mammals 100,000 years ago. Humans and mammals interacted until about 10,000 years ago to total about 15 million. And then we started to farm. We tamed animals. We tamed ourselves as well. We domesticated the world. And now, in 1900, that was the mammal biomass on the planet. In 2015, it's just exploded. And we haven't broken the planet yet, but we've got to be careful. But nonetheless, we've got a much more productive planet and high tech, and we are able to support much higher levels of biomass. But this is also supported by carbohydrates. So let's summarize that very quickly. I've got about 5 minutes left to talk. So we've trended into a warmer, wetter, less predictable, and more productive world. Sorry about this. We now live on carbohydrate-saturated diets, as many of you are probably aware of, and we've even got international recommendations that we saturate the carbohydrates even more. We live with urban lifestyles, high-tech urban lifestyles, and we've got a tech energy dependency. So the whole thing has switched away from the water, energy, food nexus, although that's still a problem, into what's now become a tech energy dependency. And what are the prospects, given that we've in a way we've trapped ourselves into this space? Let's have a look. Just a few words on prospects. We're warming the world, and it looks virtually certain that we are going to overcook and then cool down at a certain period of time into the future. So if you're thinking adaptation, don't worry about fiddling around with fine-scale climate models. I would say think more carefully about what does it mean to overshoot by a relatively small amount for a short period of time versus overshooting by a large amount for a long period of time. That's the most important thing to think about when you're planning adaptation, but I'll carry on. That's another story. So we sort of committed to overshoot, and we've been avoiding this for a long time. We've got to start thinking about that. We risk losing a lot of species, so our environment is likely to suffer the extinction of species that are Pleistocene in origin, penguins and winter rainfall karoo species that are Pleistocene derived. We face a prospect of balancing adaptation and mitigation. The more we adapt, the less we have to mitigate. The more we mitigate, the less we have to adapt. But as the Trumps of the world take control it looks like we may have to mitigate and adapt a lot into the future. In other words, we might have to use nature. We may have to use many ways to suck CO2 back out of the atmosphere. We don't know how that's going to look. But certainly, in terms of the water, food, and environment nexus, there are some very significant risks of this kind of a world, and we need to be careful of them, because this world of low mitigation, low adaptation is a thing of the past. What have we got in our favor? Well, one important thing is the demography of the planet has shifted. We get scared by graphs of exponential growth rate in human numbers. They're really misleading, because what you really need to look at is the rate of increase in world population. And if you look at the rate of increase, as Danny Dorling did in this incredible book, Slow Down, which is worth reading. He's from Oxford now. He was originally from York when he wrote this. But what he shows, and what this data set shows, is that the growth rate of people peaked in the 1950s and 1960s, and since then has started to plummet. This is one of the most important social issues of our age. Once countries start to lose population growth rate, it seems almost impossible to get it back again, because it becomes socially entrenched. But so the world's going to start running out of people in many parts, and that also has really important implications for the water, energy, food nexus. I don't think that's even on our radar yet, but this is certainly becoming politically discussed much more. But the issue is that in Africa, we still have healthy population growth rates. This is the fertility rate around the world, and you can see that most of the world is below replacement. So anything that's light blue, gray, or blue is countries that are below replacement. In other words, they're starting to run out of people. Look at China, North America, etc., Australia. But Africa has a demographic dividend. We've still got a population growth rate. So the African situation is different, and that means we need our own solutions, different from the rest of the world. Isn't that extraordinary? We need to be aware of this. And the big issues that we face it's a water, energy, food nexus issue, many other issues. We're in a warmer, wetter, less predictable, and more productive world. How do we make use of it? Are we going to tolerate carbohydrate-saturated diets and all the attendant health problems, even mental health problems relating to excessive consumption of carbohydrates? How are we going to deal with what's now fast becoming a distributed urban lifestyle with the internet? And are we moving into an era of tech energy mastery, not dependence, but we become masters of tech and energy? Where does that leave Africa with this demographic pattern? I think these are critical questions, colleagues. And I think many of us are asleep at the wheel, particularly policymakers. And I think the way that we're teaching the stuff is inadequate at universities. And so we're producing students that have yesterday's knowledge for tomorrow's world. We need to wake up. Thank you for listening.